Okay, these are notes for Tuesday, May 8th for math analysis, and this is a continuation of the lesson that we're on, 5.3. There are quite a few people gone today, so I decided to record some of this, especially since it's a continuation of yesterday's work. And so today you're writing homework 3B. Just a reminder, homework 3A is due on Wednesday, 3B on Thursday. So I wanted to get a good chunk of the notes here. I will be giving you work time today for homework, but it just made sense to me to go through the notes first and then give you some work time after that. This is not a part of our lesson, but it's something that we have to be, as good as possible at as we go. So I'm just going to remind you, and these are actually problems that are going to be trig problems in this lesson. I'm going to tell you how I do this problem. These numbers are small, 2, 1, and -1. And so I just use a guess and check method and FOIL things out in my head. 2x squared can only be 2x and x. I know that without a doubt. 1, as a matter of fact, can only be 1 and 1. There is no guesswork there. And so then when I FOIL that out, I know I have to get a positive x in the middle. So I'll FOIL it out. First terms is 2x squared. Outside terms would be 2x. Inside terms would be 1x. In order to add or subtract those and get 1x, I would want this 1x in the middle, the inside terms, to be negative, and I would want my 2x to be positive. And so I put those signs in, I check the last term, and it's all good to go. And then if you would walk me through this box method, and I'm going to have a student tell me the box method, and I'm going to write it and repeat everything you say. Go ahead. Okay, so we draw our box. You put 2x squared in this top corner box, x in the circle, and -1 in the bottom. Let me see on your picture a little bit. So you multiply the 2x squared times the -1, and you get -2x squared, and you write that kind of out there. Okay, now I just wanted to make sure I was doing it correctly. And so we get -2x squared. Then what do you do? So you have to figure out what's going to give you x, and you would put 2x here maybe, or 2x there and x there. And how do you get that negative? And so you put it as -x. Okay, put that top one as -x. Then these two. 1 is a factor on that bottom row. Just put a 1 there. And in this top row right here, the common factor is x, right? So that's what we're going to put there. Ooh, darn. Sorry, I did a little too. And let me just kind of fix that. And so the x was common, so I've got that. Going vertically on the left, there's a common factor of 2x. Going vertically on the right, there's a common factor of -1. And then am I right that one of my factors is going to be 2x minus 1, and then the other factor is going to be x plus 1. So that's another way to do that. And I can show you a third way. Sometimes if we're thinking about things that multiply to be, the last term and add to be the middle term, another method that can be used is if you have a coefficient out in front here and this, you can multiply those, and 2 times -1 is -2, or excuse me, you multiply those and you get -2. You need something that has product or multiplies to be negative 2, and then gives you a positive 1 as that middle term and has a sum of 1. And of course, there are not a lot of choices, so it's 2 and negative 1 multiply and 2 plus negative 1. And then the other way to do that is to factor by grouping. So 2x squared plus x minus 1 equals 0. Changing this x term into 2x minus 1x. And so then we can write 2x squared plus 2x minus 1x minus 1 equals 0. Factoring then by grouping, 2x is common, and then you have x plus 1. Negative 1 is common, and then you have x plus 1 equals 0. Here, then, the common factor of those two is x plus 1. When you factor those out, you get 2x minus 1. And either way, we should be able to factor that, okay? So I'm just telling you now that my expectation is that you can factor that whatever way you choose. And again, you know, I will just say this, when I was in school, I learned guess and check, and I've just used it a lot. So I just am pretty proficient at it just because. And again, 2x squared is going to be 2x times x. 15 can only be 1 and 15, 3 and 5 in any order. And so if I, you know, kind of guess and check, I'll use like a yellow marker. If I put 1 there and 15 there, the outside is 30, the inside is 1. Well, that's not going to be something that I'm going to be able to use. If I put 15 here and 1 there, I'll get 15 on the inside, 2 on the outside. That's not going to work either. So if I put 3 here, I'll get 6x. If I put 5 there, I'll get 5x. So 6x and 5x have a difference of 1. And so I want it to be negative 1, so I want 5 to be positive, and the 6 one to be negative. If I FOIL that out in my head, I'll get 2x squared minus 6x plus 5x equals, or minus 15 equals 0. So the reason I put that on there is it is my intention when we do this next part of this lesson that you are not bogged down by factoring a quadratic. So hopefully, if nothing else, that helped you review factoring a quadratic, however you take that out of there. And so is that a reminder? So yes, we are going to want to find the zeros or the roots, but it's going to be impractical for us to use the quadratic formula every time. I'm just going to tell you, you know, it's just going to be impractical. Just give me an individual head nod if you are going to be able to factor things like this generally from now on, and you just maybe needed a little bit of a review as you go through. So we're going to move on to this one and look at it carefully. It's 2 sine squared of x plus sine x minus 1 equals 0. So it's really that first problem that's in front of you right now. That's why I want that post-it or that little quarter sheet of paper in front of you right now. So for 3b, we want to find all the solutions in that interval 0 to 2 pi of 2 sine squared x plus sine x minus 1 equals 0. And I'll just write interval 0, oops, 0 has a bracket, 0 to 2 pi. And so, again, that's why I wanted to go over that, because if you missed the lesson, and that's another reason I'm recording the lesson, because I wanted to go over that, and if you're just seeing this, maybe you wouldn't notice that it's that same thing. So, in my mind, we have factored this already. So, 2 sine squared x can be 2 sine x here, and just sine x there, and that will give me that. 1 is only going to be 1 and 1, and if I make the outside ones the positive, the inside ones the negative, then I get what I want. And then it's just a matter of, just like our previous work, we're going to solve those as we ordinarily would. So 2 sine x minus 1 equals 0, and sine x plus 1 equals 0. So one case is 2 sine x minus 1 equals 0. I know I don't have the whole room here, but do we all agree that that means sine x is 1/2? Just give me a head nod right now. Sine x is 1/2 after we add 1 and divide by 2. So sine x equals 1/2, and we'll just do these one at a time. And so sine is 1/2, and again, yesterday I asked you to generate that table. If you need to have that table in front of you, then have it in front of you. You want to be able to kind of find these as you go. And all students take calculus, so the sign is going to be positive, so that means it can be in this quadrant or this quadrant. We'll X out those two as we go. Our reference angle, when is the sine equal to 1/2? What's our reference angle? Somebody just tell me what that is. Pi over 6. Our reference angle is pi over 6. We just want our solution in the interval from 0 to 2 pi, so we just are going to give any angles that we know that would be. So one is x equals pi over 6. That's just the reference angle and right in that first quadrant. The next one would be this angle right here, which has a reference angle of pi over 6. And so we're going to take 6 pi over 6 minus pi over 6. And so our second answer here is going to be x equals 5 pi over 6. So that's our two answers for that situation, or part of the equation. And then we just do the same thing over here. Sine x plus 1 equals 0. Sine x equals -1. And now that's on the quadrants. And so if you kind of think about, I'll just draw 4 points there. And they're always on the unit circle, cosine x, and then sine. Excuse me, I should call that theta because, yeah, just for x and y. So when is the y value of any of these equal to -1? And so that would be 0, -1, this one right down here. And so our reference angle is kind of 90, but our angle itself is from there to there. And, oh, I said 90, I meant pi over 2. And then this will be 0, we're at pi over 2, pi, and then 3 pi over 2. So x equals 3 pi over 2. Occasionally, just to let you know, occasionally you'll get like the same answers. Do you know what I mean? You'll get repeated answers as you go through that. So just be kind of aware of that as you go. So we should have gotten pi over 6, 5 pi over 6, and 3 pi over 2. So I'm just going to kind of put a circle around that. And those are our solutions for that problem. And that's just essentially what we do. Now, the next problem, look at it. Because this is a little tricky, but do you see someplace in there 2x² minus x minus 15? That's that other problem. We're not going to do that one right now. I'll kind of wait until everybody's here. The next one is just this application problem. We're going to skip this one for now as well. I want to do kind of the things that'll be most useful for you on doing your homework. And I wanted to get to the second part. So now this is to use trigonometric identities to solve things. By the way, let me say this, because in pre-calculus today, they were using your things. They were looking at these as they were getting ready for their final exam that we have on the wall. So actually, after class today, I have to erase all this, because the next 3 days they'll take their final exam. So maybe next week I'll put it back up there, but I'm just going to tell you that, you know, after this class period, it'll be gone for a while, but you have everything on your note card. So now we're going to have equations where we can't factor. We can't factor out a common factor. We can't factor out something or just get it, solve it or whatever. And so we're going to have to substitute in some things off of our note card in order to kind of make it something that we can use. So we're going to use trigonometric identities to solve. And so here's our first one, and this is number 5, and this is sine squared x minus sine x plus 1 equals cosine squared x. And we're doing this on the interval from 0 to 2 pi. Now, as you're less experienced with this, I'll just tell you something. If you have squared things, generally you want them to be all the same trig function. Does that make sense? You know, so that you can factor them. You don't want mixtures of trig functions as you're trying to solve something that is squared. So the first thing I would do in this particular one is get one side equal to 0, and then I either want to change it all into sines or all into cosines is my kind of thought here. So the first thing we're going to do is just subtract cosine squared. Do I need to write that under here, or can I just rewrite it writing minus cosine squared equals 0? Are you good with that? Okay, so that's what I'm going to do. I'm just going to go sine squared, oh, I'll start it in red still. Sine squared x minus sine x plus 1 minus cosine x, or excuse me, minus cosine squared x equals 0. So I just moved that over. Now, hopefully you agree that's not going to factor great, and it's not sine squared plus cosine squared, right? So that's not ideal either. But I can change cosine squared into something, right? What is cosine squared equal to? 1 minus sine squared on my note card. Do we agree with that? And so that's what I'm going to do is I'm going to substitute that in. So I'm going to say it's sine squared x minus sine x plus 1 minus, and since I'm going to write that as an expression, I'm gonna write it in parentheses, and I'm super color coding just to kind of give us the idea. So cosine squared is 1 minus sine squared. 1 minus sine squared x, excuse me, 1 minus sine squared x. And so I do have to distribute that as I go. And do you see I'm going to have plus 1 and minus 1? Does everybody see that? And do you see that I'm going to have actually one sine squared x plus 1 sine squared x, correct? So I'm going to have 2 sine squared x. And just because I have a lot of people not here, I am just going to write that one more time before I combine terms. So I've got sine squared x minus sine x plus 1 minus 1 plus sine squared x equals 0. And then combining like terms, I have 2 sine squared x minus sine x, the ones cancel, equals 0. Now that's a very manageable problem. Do you agree that it's manageable? What do I do now? What am I going to do? Is there a common something? There's a common factor of sine, and so I'm going to say sine x times, and when I distribute that out, this is going to be 2 sine squared x divided by sine x will be 2 sine x, and then minus sine x divided by sine x is 1 equals 0. And then it looks a lot like that other problem, doesn't it? Really, to me, it does at least. So I'm going to have 2 situations. These are multiplied to be 0, so I can have sine x equals 0. And I'll think about, you know, that's on the quadrant. And my points here, when is sine x equal to 0? At 0, right? So my reference angle is 0, and I have 2 answers where that works. X is 0, and x is this other one over here, pi. So that gives me those 2 answers for that one. And then for this 2 sine x minus 1 equals 0, can I jump to sine x equals what? What does sine x equal? 1/2, and I'll add 1, divide by 2. So sine x equals 1/2, and then I just go back to my, you know, table and method of doing this. All students take calculus. Sine again is positive for this one, so I'm going to get those 2 answers. I'm not going to use those 2. What is my reference angle? When is the sine of x equal to 1/2? Pi over 6. Pi over 6 again. So these are turning out to be a lot of similar seeming answers, but that's okay too. And so here we go. And so my reference angle is pi over 6, so one of my answers is x equals pi over 6. My second angle will be right here, and that reference angle is pi over 6. So if I go from here over to there, that's 6 pi over 6, 1 pi, and then I'm going to subtract a pi over 6, so that will be 5 pi over 6. So x equals 5 pi over 6 for that one. And then for this one, our solution, and am I right in thinking yesterday I said the book authors write them in order, but we don't have to write them in order. Let's see, I'll try to write them in order. Our solution is 0 pi over 6, 5 pi over 6, and pi as we go. So you can use a graphing calculator to check these as you go, but you don't have to either. If you feel confident, that's a good idea. But you can check it with a graphing calculator all the way back to this very beginning one. Put that in Y1, put that in Y2, and then look at what happens at 0, at pi over 6, and 5 pi over 6, and pi as we go through. One more problem, and then I'm just going to give you the rest of the time to work on these, because I do like you to be working on them in class. Sine x minus cosine x equals 1. And again, on the interval from 0 to 2 pi. Now, for this one, we truly, think about this. If I get one side equal to 0, I've got sine x minus cosine x minus 1 equals 0. I don't even know where to go with that. And I've got sines and I've got cosines, and things aren't going to work. The Pythagorean identity is a great thing to put in, but I have to have things squared. But if that's my goal, is really to be able to use the Pythagorean identity, I can get sine on one side of the equal sign, cosine on the other side, square both sides, and then substitute something so I have either all sines or all cosines. And we'll make that decision based on whether we have sine squareds and sine, or cosine squareds and cosine, whichever one we have, kind of both of those. So this one we kind of have to kind of pre-think that through. So what we're going to do is we're going to try using the fact where we're going to square, and we don't want to square this, because if you square that, you're going to get sine squared minus 2 sine cosine, and that's not going to be good for us. So the first thing we're going to do is we're going to add cosine x to both sides. And then that's going to be sine x equals 1 plus cosine x. And now we're just going to square both sides of the equation. Well, on the left, it's super easy, because sine x times sine x is just sine squared x equals. On this one, we have to FOIL that out. Give me a head nod personally right now. Do you want me to FOIL it out, or can I multiply it in my head? FOIL or multiply? FOIL or multiply? Okay, so the consensus is multiply. Okay with you also. The consensus is I'm going to take 1 plus cosine x times 1 plus cosine x. And I do tell you a lot, don't skip steps. But that's a step that you can make anytime. Anytime you have a binomial squared, if you can square it in your head, certainly you can write that down. But if you don't want to or whatever, you can just write it out and distribute, or use the FOIL method or whatever. 1 times 1 is 1. Outside, 1 times cosine x is plus cosine x. Inside, 1 times cosine x is cosine x. So it's going to be plus 2 cosine x. And then cosine x times cosine x is plus cosine squared x. And then listen carefully to this. So I've got to decide, I'm going to use the Pythagorean identity just like the last problem, but I've got to decide, do I want to make them all into cosines or all into sines? Let's vote. Who wants to make them all into cosines? Who wants to make them all into sines? Okay, I'm going to give you a hint. If you make this into sine, cosine squared can be 1 minus sine squared, correct? But what can cosine be? Is there anything I can take a plain cosine and make it into something that just has sine? The only way I can do it is like with a square root, and that's not going to be friendly. So the hint that I'm going to give you is at this point, when you're deciding, do I want it to be sines or cosines, whatever you have squared and not squared, that's what you want to convert everything into. So we're going to use all cosine x. So it's this that we're going to change into 1 minus cosine squared x. And so that's all I'm going to do. 1 minus cosine squared x equals 1 plus 2 cosine x plus cosine squared x. Now, essentially, I want to get one side equal to 0. I'm going to subtract 1 from both sides. I'll just subtract it there. It's going to disappear. I'll add cosine squared x, add cosine squared x. And when I do all that, the left-hand side is going to be 0. And the right-hand side, the ones cancel. And I'm going to get 2 cosine x plus 2 cosine squared x. And it really doesn't matter whether I write it in that order or back or the other way. So I'll just write it as is. 2 cosine x plus 2 cosine squared x. What do you notice? Anything common? 2 is common and cosine x is common. So 0 equals 2 cosine x times, when I distribute that out, I divide this and I get 1 plus cosine x. Now, see that little 2 that's there? It's a factor. It's going to have no bearing whatsoever on my answer. Do you know that? Do you remember that this 2 is really not going to have any bearing on my answer? So I can ignore it, or if you prefer, you can say 2 cosine x equals 0. So when I divide by 2, cosine x equals 0. Think of your table, when is cosine equal to 0? At 90 degrees. So my reference angle is, or pi over 2, sorry, I was not working in radians myself. Pi over 2 is the reference angle, so cosine is 0 there at 0, 1, but it's also 0 down here at 0, negative 1. And so our two solutions for this one is x equals pi over 2 and x equals 3 pi over 2. So we get those two answers there. Now, I have to give you a caution. Do you remember that we squared both sides of the equation at one point in time? When we do that action, it can make us do everything right, but have a solution not work in the end. And so we must check our answers when we've done that. But let me kind of finish this first. So this other one is cosine of x equals, or I will write that. 1 plus cosine x equals 0. So cosine x equals negative 1. And my reference angle to make cosine negative 1, my reference angle is 0, but for 0, it would be positive 1. So we have to use this point here, which is negative 1, 0. And so x equals pi. So we have right now 3 answers, but because we squared, and I'll write that on the slide also, because we squared both sides of the equation at some point, we must check answers to see if they work, because we could have done everything 100% right and not have the right answer. So I'll go to the very beginning problem, and I'll write it down here because this is where I'm working. Sine x minus cosine x equals 1. And I'll just kind of put those in and think about what's happening. So I'll try pi over 2. So you have your table maybe in front of you or you know it. So if I want the sine of pi over 2 minus cosine of pi over 2, what's the sine of pi over 2? 1 minus, what's the cosine of pi over 2? 0. And is that 1? Yes. So that's a good answer. I'll put a little check mark. The next one I'll check is, bless you, is sine 3 pi over 2 minus cosine 3 pi over 2. And I actually have these values right on here. So that's cosine sine. So the sine of 3 pi over 2 is negative 1 minus the cosine of 3 pi over 2 is 0. Is negative 1 minus 0 equal to 1? No, right? Do we agree that the answer to that question is no? So these are not equal. Negative 1 is not equal to 1. So this solution does not work. And so we can't count it as one of our solutions as we go through this. And then our last one, oh, let me slide that down a little. Our last one to check is this cosine, or x equals pi. So sine of pi minus cosine of pi. And again, we have it right here. So that's cosine sine. Sine is 0 minus cosine of pi is negative 1. What's 0 minus negative 1? 1. And 1 is equal to 1. Oops, check. So this one is okay as well. And so that one works as well. So then we get our final solution for this one as pi over 2 and pi. And that's why if you're ever checking an answer, you know, maybe it's in the back of a book or it's someplace, sometimes you'll have gotten a solution and it's not there. If you've squared things, that might be why it's not there. And now I'm just going to give you the rest of your time to work on things. And I'll just be picking up those little quarter sheets of paper.